on Tuesday. Okay, we were talking about solving oblique triangles. So basically, we said that oblique triangle is a triangle in which none of the angle inside the triangle is 90 degrees. Okay, so that is what we call oblique triangles. So when you want to solve for oblique triangles, we said that we have four cases. All right, the first case is where you have what we call the ASA or SAA type. Okay, A stands for the angle, S stands for the side. So the first case is where you have your angle, side angle, or side angle, angle type of oblique triangle. So that is our first case. Okay, so you are given two angles and one side unknown. Okay, two angles and one side unknown. So that is the first case, the first type of oblique triangles. Second case is where we call it SSA, side angle. So that means you are given two side and one angle is known. Okay, so that is our case 2. And then case 3 is where you also similar to 2 in the sense that you are also given two sides and one angle. However, the difference between case 2 and case 3, for case 2, all right, the angle is actually is not included. Okay, you have like side. Okay, this is the example I showed you. Okay, so you have your this side and then this side and then angle. Okay, so this type of oblique triangle. Whereas case 3, the angle is said to be what we call included angle. That's the term. Okay, included angle. So that means you are given like this, side, okay, side, and then followed by angle, and then followed by side. So that is what we call SAS. So angle is in the middle. Okay, the one that is given is in the middle or between the two sides. That is SAS. That is case 3. And case number 4 is where you are given all the three sides. Okay, one oblique triangle with the three sides unknown. So you do not know any angle. Okay, angle is not given. So out of the 4 cases, we said that the first 2 cases we are to solve using law of sine. Okay, whereas the other 2 cases we are going to solve using law of cosine. All right. Okay, and then for this law of sine, we said that, okay, this is the law or the rules, okay, or the equation for law of sine. Okay, so you have something like what we call sine A over A equals sine B over B, all right, equals to sine C over C. And you can also use this type of law, which is in the form of A over sine A equals B over sine B equals C over sine C. So either you use this one or this one, it doesn't matter. You can always use this interchangeably, also doesn't matter. Okay? Normally, when we want to apply the law of sine, it depends on what we want. If we want to find straight away the length, so we would actually use this. If we want the angle, then we will use this type of law. Okay, and in terms of diagram, in terms of the diagram, in terms of the labeling of the diagram, okay, usually in an oblique triangles, all right, we will have this type of diagram where angles are represented by uppercase letter, okay, A, B, C. So this refers to or denoted by angles, okay. So the angles are represented by uppercase letter. So sometimes you may see that in the question they give you in terms of maybe alpha, beta, gamma, something like that, or A, B, C. Okay, and then whereas the side, the opposite side, okay, the opposite side of the angle, we denoted by small letter, all right, which is the A, B, C in this case. Okay, so normally, usually this is how we label our diagram. And I have also given you this example, all right, last week. This is an example of the first case, which is you are given one angle and two sides, okay, so in the form of ASA or SAA. So you are given two angles and one side. So when you are given two angles and one side, definitely your first step, you will definitely find the missing angle, okay, because that is the last angle in a triangle. So it's very straightforward. You just subtract that 180 degrees, okay, all right, by the given angles in the question. So you straight away get your other angle, okay, or your third angle. And then definitely the second step is where you are going to find the missing length or the missing side. So in that case, it doesn't matter which one first, okay. So you can actually find the length by using law of sine. So that's is the first case. And whereas the second case, okay, second example also similar. Whereas the second case, this is where the case whereby you are given SSA type, two side and one angle. So that means only one angle is known. Okay, one angle is known, which means when you want to solve this type of case, this type of oblique triangle, all right, you have two missing angles. Okay, so you have two missing angles. So when there are two missing angles, all right, so if you want to find the other angle, all right, then it is not straightforward because there are two more that you have to find. So in that case, it requires you to use law of sine. Okay, so to find angle, all right, second angle, it requires you to use a law of sine. And for this type of case, we call it ambiguous case. Why? Because then it may actually lead you solving for maybe one triangle, or it can lead you to solve two triangles, or it can also lead you to actually no triangles at all. That means if no triangle means no solution. Okay, no solution means no triangle. So there are three possibilities for this type of case. Okay, this type of oblique triangle where you are given only two sides and one angle. Okay, so I have actually given you one example. Okay, last week. All right, whereby if you look at the example given, this is the example given is actually lead to just one triangle. All right, you are given one angle and two sides. Right, so we said that you are going to find, first you have to find the angle, okay, one of the missing angle. Okay, which angle to find first? Okay, usually from the question, all right, usually from the question, when you draw your diagram, okay, you would see that you will notice that, okay, one information you have is the given angle here with the opposite side. So this one unknown, as well as you will be given another one side here in this case, and then the opposite is the missing angle, as well as you have this missing angle here and the missing opposite side. So obviously if you want to find the first type that you want to find is actually is the angle which is the opposite side is given. So in this case you will start off by finding this missing angle using law of sine. Okay, so using the law of sine, you are going to get, all right, you are going to get first one angle from the calculator, which is actually acute angle, and that angle is actually is angle in quadrant 1. Okay, at this stage, when you compute for your sine, the value for sine is positive. Excuse me. Okay, the fact that sine is positive, you know that it will happen in quadrant 1 and quadrant 2. Okay, sine positive, all right, means that angle can actually lie in quadrant 1 and 2. So that means for this case, you got to actually consider two angles in quadrant 1 and quadrant 2. Furthermore, okay, total sum of angles in a triangles is actually 180 degrees. So that means, all right, because of that also, you have to consider angle between 0 to 180. So 0 to 180, if you are referring to the quadrant, is actually is between quadrant 1 and quadrant 2. Okay, and the fact that sine positive also can happen in quadrant 1 and quadrant 2. So therefore, all right, when you find your angle All right, the first angle that you find here, you must consider both angle. Means that angle in quadrant 1 as well as angle in quadrant 2. So this one actually we use the concept of what we have learned in chapter 2. Okay, you can actually just subtract 180, subtract by this angle. All right, then you get your angle in quadrant 2. Okay, so based on those two angles, all right, whether you want to accept or you want to reject, okay, then it depends on what is actually is the sum of the given angle in the question, all right, plus with the one that you have gotten. Okay, like in this case, one angle that you got is 34. Okay, that is your first angle from the calculator. So you add with your given angle in the question, still less than 180. So that means if it is less than 180, that means it is possible to find the third angle, okay, in a triangle. Whereas if that angle that you've got, in this case, angle in second quadrant, this is angle in second quadrant, you add with the given angle from the question, it already goes beyond 180 degrees. That means it is not possible to find the third angle because it's already beyond 180 degrees. Total sum of the three angles in a triangle equals to 180 degrees. So if just two angles you add, it already goes beyond 180 degrees. That means there's no possible to find the third angle. So this is the case whereby it leads you to just solve for one triangle. So then the angle, the first angle here, 34 here, you accept, and that 146 degrees here, you reject. So you only consider solving for one triangle. So hence, to find the third angle, then only you just subtract those two angles by 180 degrees. So you got the third angle. Then using the law of sine, you can find the last missing length or side. Okay, using the law of sine. So basically, these are the example that I stopped. All right, this example I stopped last Tuesday. Okay, so I'm going to proceed, but before that, any question? Any questions so far? Okay, so if not, then perhaps we continue. Okay, continue. We are still in this SSA type. Okay, all right, SSA type. So you have two side as well as one angle. Okay, so let's look at this question now. All right, solve triangle ABC if A equals 75 degrees, A equals 51, and B equals 71. Okay, first let me just draw a rough sketch. Just draw a rough sketch of a triangle, oblique triangle. Okay, assuming that this is A, this is B, and this is C. Okay, so you are given this is 75 degrees, and A here is 51, and B here is 71. And then this is what you want to find. You want to find these missing angles here, as well as the missing side or the missing length. Okay, so again, like previous example just now, all right, the first step is definitely is to find angle. Okay, to find angle. So which angle to find? Okay, so that is the first step. So you need to find an angle. Okay, but which angle to find? Which angle? Is it angle C or angle B? All right, is it angle C or angle B? So definitely it will be angle B. Why? Because the opposite side for B is given. You cannot start off by finding C because the opposite side here is not given. So you can't use law of sine. So that means the first step here is to find angle B. So to find angle B, so by using law of sine, okay, by using law of sine, all right, then you can establish the law like this. Sine, because you want to find angle, so sine B over B equals, okay, the one that is given already is A, so sine A over A. then sine B equals to B sine A over A. Alright, if I substitute the value, B is 71 times sine A 75 degrees over A is 51. Okay, if you compute this using your calculator, alright, you get, alright, this is approximately, alright, maybe I'll give in terms of 2 decimal places, 1.34. I hope you can also check with me. You can also compute, see whether you got the same thing or not. Okay, so this is what you got. Alright, that you got 1.34. So when you got 1.34, if you are not, if you overlook this, okay, or if you do not really understand, you can straight away use calculator and press sine inverse to get the B. And what will you get from the calculator? Calculator will give you math error or syntax error. Okay, why? Because remember the range for sine. This is 1.34, which is more than 1. Sine, range of sine must be between 1 and minus 1. So you cannot have a value of sine goes beyond 1. Okay, goes beyond 1 or even less than minus 1. So then you got math error. So this case, this is the case whereby then it is actually not possible. So that means there's no triangle that you are going to solve. No solution for this matter. Okay, so maybe I can write this as, you know, um, because the sine, okay, because sine can never exceed 1, right? So therefore, okay, thus there is no triangle, all right? Or that is the same thing as saying no solution. Okay, all right, so this is the case whereby there's no triangle. Okay, now what does it mean by no triangle? If let's say you remember, maybe you have done this before, perhaps in during school days or whatnot, you can actually geometrically you can actually use ruler and try to draw. Okay, it just so happened that this question, the given length is actually is quite long, 71, 51 like this. Okay, but if let's say you want to try to draw this, yes, you can take your ruler. Normally what people will do, take a ruler and then maybe you can just draw like one horizontal line. Okay, maybe you can just draw like one horizontal line. Okay, one horizontal line. Okay, and then take a protector where you have your angles. Okay, measure 75 degrees. Okay, so assuming like let's say this is 75 degrees like this. All right, so assuming that this is, you start with the A here. All right, because then that you measure 75 degrees, all right, for A. All right, okay, so assuming that this is your B here, it will be C here like that. Okay, so what you will do is actually you will take a ruler and measure from here, all right, to here. Okay, now if this is my B, that means this length should be 71. Okay, and then length for A is 61. So that means you take a ruler, you measure, you draw this, perhaps very long because it's 71. Okay, and then assuming that it's 71. So this is C, this is C. Then from there, you measure for 51. Okay, A. Of course, 51 less than 71 in terms of the length. So you will have something like that. Then it stops. It's like hanging. Okay, it's hanging. So in this case, this is a case whereby there's actually no triangle that you can form. This is what it means by no triangle or no solution. So from the question is actually, it's a logic question. So you can actually draw in terms of geometric drawing. You can draw using ruler, protractor. Okay, you can do this. So you will see actually there is no triangle that you can form. Okay, so this is the case whereby we say no solution or no triangle. Okay, so from the question itself, you will have something like this type of drawing. Okay, this type of diagram. Okay, so if there's a triangle like this one, if there's a triangle, that means like just now, like this one, all right, that means you only have one triangle. You have one triangle. Okay, you have one triangle. So you can draw that triangle. Okay, so this is what it means. All right, so if there's no triangle, this is what it means. That means you cannot draw. So if you draw based on the information from the question, it hangs like this. You cannot draw. You cannot form like one complete triangle. So this is what it means. Okay. All right. Okay. Any question? Perhaps I move on. All right. The next example. Let's look at this example now. Okay. For this example, okay, A is given 40 degrees. Angle A. Small a is 54 and B is 62. So again, solve this triangle ABC. All right. So I can just again draw a rough sketch. This is my ABC again. So we are given this is 40 degrees. All right. And then we are given also A here is 54. Okay. And then B is 62. So you are to find what is angle C as well as angle B and also side C. Okay. Like just now also, the first step is to find, in this case, what angle? Okay, well, from the diagram, you will see that you are given this length here is the opposite to angle B. So again, you are to find, in this case, angle B. Okay, by using law of sine. All right, by using law of sine, so you can establish your law like this, that sine B over B equals to sine A over A. Alright, so then sine B is B sine A over A. If I substitute the value now, 62 times sine 40 degrees over 54. Okay. Alright, now if I use calculator and I compute this, I will get, okay, approximately this is 0.7380. Okay, for decimal places. All right, I got this. Again, my value for sine B is positive. Sine B is 0.7380. So that means you need to consider two angles, one in quadrant 1, another one in quadrant 2. Okay, so perhaps, all right, there are two possible angles B, all right, between 0 degrees and 180 degrees. Okay, for which sine B equals 0.7380. Okay, so namely, what are the angles? Okay, namely, perhaps, okay, B1, okay, I denoted by this superscript, okay, or subscript, okay, subscript 1 for one angle in quadrant 1. So if I use calculator, you compute sine inverse now. Sine inverse of 0.7380, you will get, okay, I round to the nearest degree, I get 48 degrees. This is quadrant 1. Quadrant 1 angle. Okay, so what about quadrant 2? So quadrant 2, I denoted by B2. Okay, so this is in quadrant 2. So how do I get B2? Of course, by subtracting 180 degrees. Okay, so I'll get this one is 132 degrees. This is quadrant 2. Okay, whether to again accept or reject. Obviously, B1, because it is 48 degrees. 48 degrees is acute angle, small angle. Definitely, I will accept this. Okay, I will accept this. Because 48 degrees, even if I add with 40 degrees from the question, still less than 180. That's how I check, isn't it? That means, how do I check? Is by adding, all right, 48 degrees plus with the given from the question, 40 degrees. So this is still less than 180 degrees. So that means this one is possible. So that means there's another possible angle, third angle that I can find. Similarly, I also need to check for my B2. B2, which is 132 degrees. So if I add with the given from the question, which is 40 degrees. Okay, this is actually still less, isn't it? It's 172. So still less than 180 degrees. Okay, which means again also there is another possible angle or the third angle that I can find. So in this case, I will also accept this. Okay, so that means I am going to solve for two triangles. In this case, this is the example whereby there's two possible triangles that I am solving with the given condition from the question. Okay, so therefore there are two triangles. Okay, with the given condition. Okay, with the given condition means with the given condition from the question. Right, so namely triangle 1 and triangle 2. So then I can solve separately one by one. So let me say first is triangle number 1. Okay, let's say triangle number 1. Okay, we are using the same information as in question for A, angle A, small a and small b. Okay, so the condition given from the question is still applied. Okay, so the only different now is, okay, is our B, okay, because then B1 is 48 degrees. So assuming that now triangle 1 I denoted by subscript 1. So B1 we have just found to be 48 degrees. So that means I can find, okay, I can find my C1. All right. So C1 in this case, definitely very straightforward. It will be 180 degrees minus B1 minus A. A is 40 degrees. Okay. So A is 40 degrees. So in this case, I get 92 degrees. That is my C1. Okay, then the next step is now I can find my missing length, which is my small c1, by using law of sine. Okay, by using law of sine, then I can write this as c1 over sine c1 equals a over sine a. Alright, so then c1 equals a times sine c1 over sine a, which is then a, small a, which is 54, times sine, okay, c1 is 92 degrees over a is 40 degrees. So if you use your calculator, okay, what do you get? It roughly, alright, approximately, if I round this to the nearest length, it will be 84 unit. Okay, so that is my C1, and that is my solution for triangle number 1. So now I can move on and solve for my triangle number 2. My triangle number 2, which is my B2 just now, I have found to be 132 degrees. 132 degrees. So then, next thing that I want to find is definitely my angle, which is my C2. So in this case, C2, straight away you subtract, okay, 180 degrees, subtract by 132, as well as the given angle A from the question, which is 40 degrees. Okay, so 180 minus 172, so then you got your 8 degrees. Okay, then only finally you can find your last missing length, which is your small c2, by law of sine. So then you can write it as c2 over sine c2 equals a over sine a. Then c2 equals a times sine c2 over sine a, which is then you substitute a just now is 54, sine c2 is sine 8 degrees, okay, sine 8 degrees over sine a is 40 degrees. So if you compute this, all right, using your calculator, you will get this roughly 12 unit length. So then only finally you can conclude. Therefore, all right, there are two solutions or two triangles. That means, okay, so for triangle 1, the solution is, okay, just now your B1 just now is 48 degrees. Your C1 just now you computed as 92 degrees, as well as your small C1 roughly 84 unit length. Whereas for triangle 2, okay, the solution is Okay, just now B1 is 132 degrees. And then your, B2, B2 is 132 degrees. And then C2 is your 8 degrees. And small C2 is 12 unit length. So that's your solution. Okay? All right. What does it mean by solving two triangles? Or in other words, what do we mean by this solution has two triangles? It is not about two separate triangles. It is not about two separate triangles. If you have something like this just now, just one triangle. If you have triangle just now, like hanging, something like that, this is no triangle or no solution. Okay? And solving for two triangle means you will have something like this. Maybe you have something like this. Like that. So this is where you have two triangles. Okay, your triangles looks like that. Okay, so this is what it means. Okay, all right. Okay, any questions? So basically, if you are given case number 2, all right, which are the side angle. Okay, this is what we call the SSA, side angle. So this is what we call the ambiguous case. Solution will lead to either one triangle, solving for one triangle, or no triangle, or it can be two triangles. Okay, it can be two triangles. Okay, all right. Okay, any question? Any questions? Okay, can you all understand this? Can you all follow? Ambiguous case? Is that okay? All right, okay, let's move on. So case 3 and case 4, as we said, that it will be using the law of cosine to solve. Law of cosine can be straightforward. Okay, law of cosine is straightforward. And I think that, I hope that you are actually already familiar with this type of formulas or this type of law for law of cosine. It is still about oblique triangles, all right? Still about oblique triangles, but this time, okay, the triangles given is where we call it side angle side. Side angle side means maybe like this side, and then angle here, and then this side. Okay, so this is what we call included angle, angle in the middle, angle in the middle. Okay, or you can have like, for example, maybe you have side angle side, can be like that. Okay, so you have side angle side. So again, this is what we call included angle. Okay, included angle is given for this case. And if you look at this type of triangle, okay, definitely this side and this side and this angle, these are all different letters. Letters means A, B, C, D, E, F, G. So different letters. Okay. So if you look at the right hand side of your formula, all this right hand side. So if you look at the first one, right hand side you have your B, C, alright, and then A. You see, and because the angle is 1, so you will have in the formula only one angle here for the right hand side. The equation just require one angle. Okay, so the question or the law requires one angle, and the two sides. So if the two sides are B and C, you will be given angle A. If the two sides given are A and C, you will be given angle B in the question. If the two sides A, B are given, you will be given angle C in the question. Okay, so then that particular type of oblique triangle require you to actually use law of cosine. Okay, using law of cosine to find the length. Okay, so to find the length. So that means for this type of case, because you are given already the two sides are given from the question, you will definitely start off by finding the missing length or the missing side. You are to find the missing length or the missing side from the question. That will always be your first step. So the first step is to find the missing length by using law of cosine. Okay, so let's look at this example here, the one that I've already written. Okay, solve triangle ABC, where you are given, all right, A is 13, C is 6, and given angle B is 20 degrees. Okay, so even if, let's say, for this question, you don't sketch, you know that you are given AC and then angle B. So if you look at your formula here, all right, the one that you are going to apply is something like AC cosine B. AC cosine B. So that means it's like your second formula here. A squared plus C squared minus 2AC cosine B. So you have AC and B, right, from the question. So it will be like this question, this law, all right. That means you are to find the missing length here is actually is B, because you are given A and C, so the missing length is B. Okay, but if you want to draw, go ahead, just draw a rough sketch, then you can see clearly also. All right, let's say this is A, B, and C. All right, so the one that is given is 13 here, and then 6 is here, and then angle B is here, which is 20 degrees. So this is the case whereby I said just now, side, angle, side. So SAS. So this angle is what we call included angle. Alright, so our first step definitely to find the missing length here, which is our length B. So our first step is to find B by using law of cosines. So by using the law of cosine, so the one that I'm using is actually the one which is the B squared equals A squared plus C squared minus 2AC cosine B. Okay, all right. Okay, which means that if you want to find B, you are going to take a square root of A squared plus C squared minus 2AC cosine B. Okay, so if let's say I plug in the value, it will be 13 squared plus 6 squared minus 2 times 13 times 6. Okay, cosine 20 degrees. So you just need to compute that one. Straight away, just compute everything inside the square root, then take the square root. So do this properly, correctly. What will you get? 13 squared plus 6 squared minus 2 times 13 times 6, and then cosine 20 degrees. Okay, then take a square root. Okay, you get roughly, if I round this to maybe 1 decimal place, I hope you also get this, 7.6. Okay, 7.6 unit. That is B. Okay, that is B. All right, so now I can find, the next step is now to find my missing angle. So in this case, my missing angles are 2. All right, my missing angle are this as well as this. Okay, A as well as C. So now I've already gotten my B here. Okay, this B I've already gotten, which is 7.6. Okay, so next is to find missing angles. Okay, so whether it's angle A or angle C, it actually doesn't matter. Okay, which one which? You can start off by finding angle A, or you want to find angle C first, so it doesn't matter for your second step. But what matters is that, okay, to find angle, let's say I want to find angle C, for example. Okay, it's just that if you want to find angle in this case, okay, you have two options. You have two options, or you have two choices. You can either use also law of cosine, or you can also use law of sine, because the fact that now you already knows all the sides, so you can actually use law of sine for your second step to find the next angle. All right, and if you want to find using law of cosine, also can. All right, I'm going to use law of sine, but I can just show you quickly to use law of cosine. So if you want to find using law of cosine, because what you want is angle C, that means you are going to look at this formula, the last one, which is the C squared equals to A squared plus B squared minus 2AB cosine C. Because you want the C, you want the angle C, so you are going to use that. So you are going to use this. The C squared equals A squared plus B squared minus 2AB cosine C. Then you got to rearrange. Okay, bring your minus 2AB cosine C to left hand side, C squared to the right hand side. That means you have something like this. Okay, then only cosine C. All right, you do this, divide by 2AB, then only finally to find C, it requires for cosine inverse of the whole thing. Then only you'll get your C. So if you want to find angle using law of cosine, well, it considered like a bit more work, a bit tedious. You got to rearrange, all right, correctly. Then only you can get the right answer for C. So this is using law of cosine, but I want to use law of sine because law of sine is much easier. Okay, again, as I said, it can be done. All right, it can be done using law of cosine. You just need to rearrange. But if I want to use law of sine, okay, then what I need to do is, okay, if I want to use law of sine, then I can establish my law like this, that sine C over C equals, okay, sine B over B, all right, then sine C equals C sine B over B. Okay, in other words, if I want to find C, then it will be my sine inverse of, okay, C just now, C 6, B is 20. C is 6 times sine 20 degrees over, okay, small b I just found just now, 7.6. Then I can just use my calculator straight away. All right. All right. If I round to the nearest degrees, I can write it as 16 degrees. I hope you got the same answer. So law of sine is much shorter as compared to law of cosine. Okay, because law of cosine, you got to rearrange your equation. So you have the tendency of making mistake is actually there if you are not careful. Okay, because you got to rearrange your formulas. Okay, to find the C using law of cosine. But you can actually, after this, you can try for this question, you try and use your law of cosine. And you must see that you will get the same answer here, which is 16 degrees. This is, we round to the nearest degree. During exam, if we want you to round, we will mention like round to the nearest degree, or, round to one decimal place, etc. But if we don't mention, it's up to you. Okay, any answer, all right, we will accept. Okay, as long as it's correct. So this is your angle C. Then finally, the last step is to find the last angle. In this case, is to find angle A. So this one is quite straightforward. That to find A, basically you just subtract 180, right? Minus 16 degrees for C, and then minus just now 20 degrees for your B from the question. So if you do that, you'll get this is 144. Then only you can conclude, therefore, all right, the solution, all right, the solution is, okay, then your small b just now, which is your 7.6, and then your angle C, which is 16 degrees, and angle A, which is 144 degrees. Okay, so this is case 3 example. Okay, case number 3, where you are given SAS type, side, angle, side. All right, okay, it's already 3 o'clock. Any question? All right, before I'll give you all a break. Any question to ask? Are you all okay? Can you all follow? Is it understood?
Yes.
Okay, all right. So we'll take 5. Okay, then we will resume back around 3 7. Okay, 3 7 or 7 minutes up to 3. Okay, so 5 minutes break. All right, okay, can I continue? Okay, let's continue this, everyone. This is now the fourth case, or case number 4, is where 3 sides are known, or 3 sides are given. So you are given a triangle whereby, all right, all the 3 sides are given. So none of the angle is known, okay? So that means when you solve, you want to find all the missing angles. Okay, we don't have to draw the triangle because since these are all the 3 sides, but if we want to draw also can, just a rough sketch. Okay, just a rough sketch. All right. Let's say this is ABC again. So you are given, this is A is 8. All right, and then B is 6, and then C is 7. So then you want to find the missing angle. So the one that is missing here is all angles. So in this case, you want to find angle ABC. Okay, you can actually start off with any angle, whether it's A, B, or C. But there is actually a guideline, or there is a suggestion that you might want to, okay, there is a guideline or there is a suggestion that you might want to find angle or the largest angle, which means you are referring to the longest side. Okay, because the one that is actually uh, the angle that is the largest angle is the one that has the largest side, the opposite side. So that means if you look at this value, the given A, B, and C. All right, so this A is actually is the longest, okay, the longest side. That means the angle A is actually is the largest angle. So the guideline says that perhaps you might want to identify the largest angle. So that is your first step to find that particular angle. Okay, so that is just a guideline. But if you don't want to follow, that is also fine. But it's actually good to follow the guideline. Okay, so in this case, all right, if my A is 8, which has the longest length or side, that means my first step is I want to actually find my angle A. All right, by using law of cosine. Definitely, it has to be law of cosine. I cannot use law of sine because I must have actually one known angle. Then only I can use law of sine. But in this case, none of the angle is known. So the first angle that I need to find, I must use law of cosine. Okay, I must use law of cosine. So if I want to find angle A, definitely law of cosine that I want is the one that which has cosine A. So that means the law is the one which is A squared equals to B squared plus C squared minus 2BC cosine A. This is the one. Okay, then I need to rearrange like just now I've showed you. All right, I have to rearrange, right? That B squared plus C squared minus A squared. Then cosine A is B squared plus C squared minus A squared over 2BC. Then only to find angle A, it will be cosine inverse. Okay, so if I plug in the value B squared plus C squared minus A squared over 2 times B times C. Okay, so use your calculator and compute this. Okay, give me maybe one decimal place maybe. Okay, round to one decimal place. Take one decimal place. Okay, I hope you also compute this. Okay, so you will get this is 75.5. If I'm using I just take one decimal place, 75.5 degrees. If you want to round to the nearest degree, then you will say 76. Okay, so again, as I said, if we want you to round to a nearest degree or any decimal places, all right, during exam, we will actually tell you in the question. If you don't say anything, it's up to you. Okay, so this is my angle A. So first step is using law of cosine. Okay, then the next angle, then only you have the option. Okay, so the next angle, you have the option. So either you use law of sine or law of cosine. So in this case, it doesn't matter. So let's say the next angle I want to find angle B. Okay, I want to find angle B. Since I already gotten my A, so next is B. So then I'm using law of sine. That one will be much easier, much faster as compared to perhaps cosine. You got to rearrange correctly and make sure it's correct. Okay, so law of sine, so I can establish my law of sine like this, which is then sine B, because this is what I want, sine B over B. All right, so I've already gotten my A, angle A, so then sine A over A. Okay, so then sine B is B sine A over A. So then to find my B, it will be my sine inverse. Okay, so B is 6. B is 6. Sine A just now we have found 75.5 degrees over small a, length A is 8. So this is what you need to compute, all right, to find angle B. So if you do that, you will get okay, you got roughly again one decimal place, so 46.6. Okay, all right, then only the last one is your angle C. So this one's straightforward. So to find angle C, so this is straightforward. 180 degrees subtract by the two angles that you have found just now, 46.6 as well as 75.5, which is then 57 0.9. Then we can conclude. Therefore, the solution is A is 75.5, B 46.6, and C, all right, 57.9. Okay, all right. Any question? So again, basically, this is a law of cosine. This is case 4. Even case 3 also just now, which requires law of cosine, you would see that case 4 and case 3 and case 4 is the case whereby the first step is definitely you have to apply law of cosine. Okay, your first step is to apply law of cosine. All right, like case 3 just now, case 3 is when you are going to find your first step for case 3 is to find the missing length by using law of cosine. Okay, and then after you have used law of cosine, first step, second step, you will use law of sine. Okay, and then the third step, mostly you just need to subtract 180 degrees to get the last angle. Just 180 degrees subtract by the two angles. And for case 4 also, you have seen that you have a missing angles. All right, when you solve, it's actually solving for all the missing 3 angles. But the first step to find angle is by using law of cosine. Then the second step only you use law of sine. Okay, and then the last step, you just use your 180 degrees minus the 2 angles. So basically, you will see, you have seen that for case 3 and case 4, you have actually 3 steps. Okay, most of the time there are 3 steps that you have to solve. And those 3 steps, the first step, definitely it will require you to apply law of cosine. Then second step, actually you have options, law of cosine or law of sine. But again, we said that the much easier one is actually using law of sine for the second step. Okay. So the third step, basically, you just need to find the last angle in the question. Then you just apply 180 degrees, subtract with the two known angles. Okay, any questions? So this is all about law of cosine. All right, case 3 and 4 requires law of cosine to solve. Case 1 and 2 requires law of sine. Okay, all right. Let's move on to area. Area of a triangle, because we have actually dealt with oblique triangles for case 3 and case 4 just now, then we can also have another forms of area, okay, formula area, okay, or areas formula. All the while, okay, what you have learned to find area of any triangle, okay, or area of a triangle, if you recall, you have this formula. This is actually is the basic formula. Half times base times height. Half times base times height. This is actually is the basic formula for the area of a triangle. Half times base times height. Okay, now that you have these two type of oblique triangles, namely the SAS, okay, side angle side, the case 3, all right, triangle, as well as side, 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 case 4, all the 3 sides. Okay, then you actually have another 2 more formulas for finding area of that type of oblique triangles. Okay, so the first formula here is actually is where this is for SAS type of triangle. It's a SAS type, the one with the included angle, case 3. Okay, so this is the SAS type, like that. Okay, or you may have SAS type like this. Okay, so when it comes to this type of triangle, so to find the area, you have this formula. You have half AB sine C. That means when you are given this type of formula, you are given 2 sides and one included angle. All right, one included angle. Two side, one included angle. So this is where you see you have two side AB. AB is two side and then one angle C here. And this angle is the included angle. Okay. So if let's say you are given, for example, let's say this is the triangle ABC, and then the one that is given maybe is this one, C is given, and then MA is given. All right, definitely you are going to be given this angle B. So if let's say question asks you find area of this triangle, find area of this triangle. So you will see you have you are given A, you are given C, as well as you are given B. So you are given A, C, and angle B. So A, C, and angle B. So then this is the formula. Okay, half times A times C times sine B. So this actually is straightforward. This is also straightforward. Okay, let's do straight away example. Okay, let's do this example straight away. All right, find the area of the triangle given A equals 7.0 feet, B is given as 9.3 feet, and C is given as 86 degrees. This is angle C here. All right, so even if we don't sketch, all right, sketch a triangle, okay, in fact we don't have to, you can just see what are given: A, B, and angle C. Okay, A, B, and angle C. So basically this one. Okay, half times A times B times sine C. Basically half times this times sine of this. So it actually is quite straightforward. Okay, finding area using this formula. So you can just straight away to find area, straight away you can apply half times A, B sine C. Okay, so then half times A times B times sine 86 degrees. So if you use your calculator, okay, so roughly, approximately, okay, maybe I'll write in 2 decimal places perhaps, then you get 32.47. Okay, I hope you got the same thing, feet square. Okay, all right. Okay, maybe I have another one here. Let's look at another one. Okay, find the area of the triangle B equals 6, C equals 4, set 3, and A equals 30 degrees. All right. So again, if you look at the formula, or if you look at the question, you're given B, C, and angle A. So then formula is straight away, actually you can remember this formula by heart. Depends on what is the given information. Okay, so based on the given information, straight away it will be half times B times C sine A. So it is half times B times C times sine A. Okay, all right. So half times 6 times 4 sec 3 times sine 30 degrees. So roughly 10.39 units square because the area. Okay, any question? So basically this formula area is for oblique triangle, all right, for case number 3. It's a side angle side. Okay, side angle side.
Madam,
So that means you know, if you want to find, if you want to use this formula area here, okay, this formula area, you must know that the angle is actually is the included angle. This is what it means. Angle is the included angle. So no matter what type of case of the oblique triangles you are given, if you want to use this formula, then it has to be, you must know that C or angle here has to be included angle. So you cannot just simply pick any angle in the oblique triangle, pick any two side. No, cannot. Okay, any question just now? I thought there's someone wants to ask. Anybody would like to ask question just now? Anybody? Okay, all right. Okay, you have another one formula. Okay, so basically after this, you have actually 3 formulas for the area of a triangle. One is half times base times height. That is the basic formula. Okay, another formula just now is half times AB sine C. That's a second formula. Third formula is this one, what we call the Heron's, okay, Heron's formula. Heron's formula is where you are using 3 sides. Okay, you are using just sides, no angle. That means, if let's say you are given one oblique triangle where you just be given all the 3 sides, no angles are given. Question asks you to find area. Then this is the formula. Okay, this is the formula which is concerning with all the 3 sides only, or dealing with just all the 3 sides. Okay, and if you look at the formula, Heron's formula for area is this, which is square root of s times s minus a times s minus b times s minus c. A, B, C are the side, the length of the sides of a triangle. So s is actually is this, is a sum of the 3 sides divided by 2. Okay, sum of the 3 sides divided by 2. That is S. Okay, so if let's say, for example, you want to find area of this triangle given A is 5, B is 6, and C is 9. No angles here. So you cannot use just now the formula half AB sine C. You cannot use that. So you can just use this one. Alright. If you want to use just now a half AB sine C, you have to find angle. Okay, it can be done. It can be done because you have all the 3 sides. You can find angle. Just now we have case 4 just now where you require to use law of cosine to find the angle. So once you got the angle, then only you use your half AB sine C. But the angle must be included angle. But if you have this question, this formula, all right, why must you want to find angle? That will be like more work to do. So might as well straight away find area using this formula or Heron's formula, where you just first compute the S. All right, you compute the S first because you need the S into the formula. So S basically is the sum of all the 3 sides. So that means 5 times plus 6 plus 9 divided by 2. So 5 plus 6, 11 plus 9, 20 divided by 2. So it's 10. Alright. Then only Therefore, to find the area, okay, you have this S times S minus A, okay, times S minus B times S minus C. Okay, all right. So this is the formula, the Heron's formula. So if you use calculator, 10 times 5 times 4 times 1. So you get, take square root, you get roughly 14.14 unit square. Okay. All right. Any question? Okay, so now you have actually three formulas to find area of a triangle. Half times base times height, and then half times AB sine C, all right, and the angle is included angle, as well as this Heron's formula, which is S times square root of S times S minus A times S minus B times S minus C, all right, where S is actually is the sum of the three sides divided by 2. Okay, any question? Any question so far? Okay, so far? All right.
No.
Okay. So if there's no question, then we come to the last section, which is the application of trigonometry. Okay. So last section for this topic is on the application question. So in the book also you will see the exercises for this section. All are about application, all application or real life application of this trigonometry. Okay, let's look at this example. Maybe if you want, you can, I'll give you like sometimes to copy first the question. You jot down the question, then we will discuss. Okay, so you can copy down the question quickly, then we can discuss this question, this example. Okay, okay, all right, and done. Okay, done copying. All right. Okay, let's look at this question. The angle of elevation to the top C of a building from 2 points A and B on level ground are 50 degrees and 60 degrees respectively. The distance between points A and B is 30 meters. Find the height h of the building. Round your answer to the nearest unit. So you are given a diagram here. So basically, if you read the question carefully, this question just to describe this diagram. Okay, the question is to just describe the diagram, and this 50 degrees, actually that is a degree. Okay, that is 50 degrees, 60 degrees is angle. Okay, so basically 50 degrees and 60 degrees, these are what we call angle of elevation. Okay, angle of elevation. Okay, so you have something like this is a horizontal line, and then if you have like that, this is angle. We call it angle of elevation. Okay, angle of elevation or elevation angle. Okay, all right. Okay, so then so and then distance from A to B is 30 meters. So question asks you to find this. Question wants us to find what is H. This is what we want. Okay, what is H? All right. Now, if I want to find the H, okay, if I look at this, basically I have like two triangles. This is one triangle, okay, and then I have another triangle. Okay, so basically I have two triangles here. Now, if I want to find H, if only I can find my D, then I can establish what we call trigonometric ratios. All right, trigonometric ratios, which relates to H, D, and this angle. After all, this is a building, all right, and this is actually, it's a straight building. Supposedly that these are walls, and this is actually 90 degrees angle. Okay, 90 degrees angle. So we have actually a trigonometric ratios, right, in chapter 2. If we have, this is a right angle triangle, this is angle here, and then this is what we call, this side is what we call opposite. This is what we call hypotenuse. Okay, so if this is angle, this is opposite, this is hypotenuse. So the ratio, the trigonometric ratio that you are talking about, which relates to these three, is actually what? Is sine, isn't it? Okay, that sine 60 here, sine 60 equals to H over D, right? So our job is to find D. Our job is to find the length here. In this case, we label this as D. So how do we find this? How do we find this D? Okay, then we look at this triangle. So this triangle, this 50 degrees is given, and we do not know this, and we do not know this. So if we want to find D, all right, if we want to find D using law of sine, okay, using law of sine, all right, if only we can find the C, angle C, then we can actually use that law of sine, because we need, because we are given here, this is the opposite length, opposite side to angle C. It's the opposite length, okay, opposite to angle C. So if we can find this angle, then we can use the law of sine to find our D. Okay, all right. Now, if you observe carefully this triangle, okay, if you want, maybe you can say you have two triangle. Maybe you name your triangle. Maybe this is triangle triangle 1, let's say triangle 1, or let's say triangle A, and this is triangle B. Okay, just name your triangle. All right, okay, if let's say I just scribble on the diagram first, okay, I'm not yet writing the solution, I just scribble. If I want to find angle C, if only I know this one, this angle B here, then I can find that C, isn't it? And the fact that we are given this 60 degrees, we can definitely find out this. Remember? How do you find that? You just need to subtract, isn't it? 180 degrees. 180 degrees subtract by 60, right? Then you get this is actually 120 degrees. This is actually is the concept of, remember, the name is supplementary angle. Okay, this is what we call supplementary angle. Okay, remember the word complementary last time? Complementary and supplementary. Complementary angle is a sum of two angles, sum of two angles equal 90 degrees. That is complementary. Supplementary angle means sum of two angles equal 180 degrees. That is what we call supplementary angle. Okay, that's just the name, right? So if that is 120, the supplementary angle, then of course 120 plus 50 is 170 degrees, and the fact that the sum of all angles in a triangle equals to 180 degrees, so then this is actually just 10 degrees, right? Then you can actually use your law of sine to find D. Okay, so of course you have to write some steps, okay, for solutions. So if I were to write some steps, okay, so maybe I need to just write first, consider triangle A. Okay, consider triangle A. Triangle A first. Okay, all right. So let's consider triangle A. So then what we can do is to find angle B for triangle A. So that means in this case, our B, using the concept of supplementary, is 180 degrees minus 60 degrees, which is then 120 degrees. So that is our B. Then only, all right, to find angle C in our triangle A, all right, then again, our C will be also 180 degrees, subtract by 120, subtract by 50 degrees. That means in this case is 10 degrees. Okay, then only our last step for this one is to find D. To find D. Alright, so again, D is this length. Okay, D is this length. Okay, this length. So we can use law of sine. So how do we establish our law of sine for this? So it will be D over sine 50 degrees equals 30 plus or 30 over sine 10 degrees. That is the formula, or that's how we establish our law of sine for triangle A to find the D. Okay, all right. So again, D over sine 50 degrees equals 30 over sine 10 degrees. All right. So let's write this. To find A using law of sine. So now D over sine 50 degrees equals 30 plus 30 over sine 10 degrees. Okay, then we can get our D. So D will be 30 times sine 50 degrees divided by sine 10 degrees. So if you use your calculator, again, so 30 times sine 50 degrees divided by sine 10. Okay, so 132.34, etc. So I just round it to perhaps to the nearest length, which is just 132 meters. That is D. Okay, that is D. Then only now we want to find H. We can find H because we have found D. Okay, so we have found D, so now we can find our H based on triangle B. So now we consider for triangle B now. Okay. Okay, so consider triangle B, or you can say triangle B, or for triangle B, then straight away you are going to find H, the height. Okay, then again, as I said just now earlier, that you can just use your trigonometric ratios between H, B, and 60 degrees. So that is actually is sine. Sine 60 degrees equals to H over B. So sine 60 degrees equals to H over B. And therefore, to find H, basically B times sine 60 degrees, or D is just now 132 meters times sine 60 degrees. So if you use calculator, alright, you get, okay, around it also is 114 meters. So therefore, the height, I can conclude, the height of the building is 114 meters. Okay, any question? Okay, carry on, follow. Is it understood? Alright. Okay. Alright, okay. I have one more question, which I would like you to try on your own later. Alright, not now. And then we will discuss this on Tuesday next week. Can you all either you copy or you just take photo? Can you do that? Okay. You can take this photo. Alright, this question. So this is like your homework also. Alright, beside your assignment. Right, as well as actually a question in the book, beside the assignment also, you also need to actually do question in the book for tutorial next week. Tutorial next week, maybe let me just look at the book, because then next week we can discuss our chapter 3 questions. Oh, okay. Exercise chapter 3. Wow, quite a number of application. You have a lot. You have a lot of application question for exercise chapter 3. Okay, maybe I don't think that we are able to do all. Maybe I need to select later on. Okay. All right, but you can actually start looking at your textbook, looking at all the question in the exercises. Okay, for each section you have also question exercises like 3.1, exercise 3.2, 3.3, 3.4, and 3.5. That's the exercises question in each section. All right, together with exercise chapter. Okay, at the end of the chapter. All right, so you can actually start looking at this, because our chapter 3 is until here. So today we can actually finish our chapter 3. But this example 2, I would like you to try first, and then on Tuesday we will discuss. Okay, because earlier this morning also I did not have a chance to do this question with that section. Okay, the earlier section 1/1 and 1/2. So again, I also asked them to try. So then on Tuesday, because it will be combined, all of you in one session, so then might as well I straight away do the same thing we discuss. If you can do this question, you can find the solution, then we can just discuss quickly. on next Tuesday. All right. Okay, so I think that you have already taken photo for this question so that you can later on either today or maybe tomorrow or during weekend you can try this question. All right, plus with maybe questions in the book, okay, as well as assignment perhaps. Okay, then on Tuesday I think we can discuss this question together with the other groups, other sections. Okay, is it understood? So we can end the session early today. All right. Okay, class.
Okay,
Is it
madam.
understood?
Okay,
All right.
madam.
Any
Thank you.
question? All right.
Thank you,
Okay.
madam.
All right. So
Thank
if
you.
there's no
Thank
question,
you,
we can end the
madam.
session today.
Okay,
We can
thank you,
end the
madam.
session early today. All right. You're welcome. Okay. So thank you for
Assalamualaikum.
your attention. Waalaikumsalam. So thank you for your attention. Okay.
Thank you, madam.
Thank you, madam.
Okay. Welcome.
Thank you,
Assalamualaikum.
madam.
Waalaikumsalam. And have a good break. Have a good weekend and stay safe. Yes. Boleh, can. Yes. Okay. All right. Let me see. Case what? 3 or 4? Case? Case. Is it? If you're talking about lot of questions, that means case 3 and 4, isn't it? Okay. Is it this question? Okay. Okay. This. Okay. Yeah. Okay. This one. Yes. You can. Yes. Must be. Yes. Okay. What did you get? Okay. Because this is actually that. Yes, this is actually correct because we are using approximation. Okay, because this is approximation. So if it is like 15 point something, okay, then it's actually is close enough with the 16. Actually, because we are using decimal. So if let's say if we have any approximation value, let's say from this B, okay, let's say from this B, we take more decimal places because I'm taking only one decimal. So if I take one decimal places, of course, you know, my approximation as compared to if I take more decimal will be more accurate. Okay. But if let's say you use your law of cosine and then suddenly you got like 15.1, this is already 16. Okay, the difference by that one is actually not that trivial. It means that it is correct. Unless suddenly you use your law of cosine, this is 16 degrees, and then you got like 20, 30 degrees. That is actually is too much difference. Then it shouldn't be like that. Okay. Yours 15.1. If let's say I use this one, not 7.6, maybe if I use like more decimal places, then it could be that I will be like the number will be close to you, close to the law of cosine, using law of cosine. That is actually is fine. Okay, so it is expected. There's a difference in terms of decimal. Okay. All right. Okay. Okay. Uh-huh. Oh, actually, this one is just approximation. That means normally when we compute and then we use decimal kan, we use calculator, and then our numbers got like with a decimal. So we round the number. So that means we are using approximation. It is not exact value. It's not exact. If it is exact value, we will use that equal sign. Okay. So but if let's say in the exam, okay, in your scripts, you use equal, it's still fine. We don't actually penalize student for this type of notation. Okay. So instead of this type of approximation and then you put equal, then it's fine. Okay, we will accept. But this is just approximation. Normally when we deal with approximation value where we use calculator and then we round to one decimal, two decimal, or maybe to the nearest degree. So we actually use approximation value. It is not exact. Exact value is like previously you've learned 1/2, 4/, cert 3, or cert, these are all exact value. This is exact value because then you don't round. That is what we call exact value. But when the moment you use calculator, if you use calculator, suddenly you use calculators and then calculator value is 0.23. Stop. That is considered exact value also because you don't have decimal after that. Okay, like your 1/2. If you use calculator, isn't that calculator just give 0.5? That's it. So you don't round, you don't approximate. So 0.5 is considered exact value. Okay, but like all this question, when I use calculator, I have actually more decimal places, so I round it. So when the moment I round, that's when I am using approximation. Anggaran. Okay, approximation. It's not really exact value. Okay, so that is what this notation is all about. Okay, all right. Okay, you're welcome.